W1VLF. Hey everybody, my name is Paul, W1VLF, and welcome back to the lab. It's been an awful long time since I made a video, and but there's an awful lot going on too. So I wanted to show something here. Looking at the forums, there's been a lot of talk about calibrating your AirSpy or SDR play and what to use for calibration, what frequencies, and good sources for calibration. And then the other question, a really big one is, I got one of those Leo Bodnar boards, little modules. I have just the single frequency output. But anyway, how do I know that my R2 is locked? There's no indication on it. And so I thought we'd go over to the Ham Shack computer, plug this stuff in, and look at 3 ways that I can think of to know that you are absolutely locked to this board, to this little device. And let me tell you, this is great. Look how small this stuff is, okay? And the things you can do with it are just incredible. So when we get back over to the computer, the Ham Shack computer, I'm going to assume that you have one of these, that it's the software I'll be using is for this box, not the dual output. So you'll have to figure that part out because I don't have one of those. I'm going to assume you already have it connected, and we'll connect it up. We'll turn this thing on as if you had just got both of these pieces and it's running, but you don't know if it's locked or not. So I'll show 3 different ways that you can tell that this oscillator is driving this particular unit. So let's go over to the Ham Shack computer and do that. I'm going to be using a UHF broadcast station to do this. There's a local RF channel, number 33, that I know is locked to GPS. So on one hand, you'll have a transmitted signal that's locked to GPS, and you'll have this which is locked to GPS, and at 577 megahertz, whatever I forget what the conversion is to, but you're going to have Hertz resolution or Hertz reliability as far as where this thing is actually receiving when you think it is. So anyway, let's head up. I'm going to assume you already have this hooked up, right? You know, you're ready to go with your cables and everything, and you have one of these little boxes. So again, I guess for the 3rd time now, let's head over there. Hey everybody, W1VLF back, and we are over at the ham radio desk computer system here. And as you can see, I am tuned to 572.309.404 megahertz. And that happens to be a local digital television broadcaster here in the Connecticut area. And I know people who work there, and this is indeed a DTV station. This is the pilot carrier. 309 kilohertz, roughly above the bottom edge of the channel. And this particular station is indeed locked to GPS. So what's the setup? The setup is the R2. The R2 is being locked currently by the Leo Bodnar board. Pop Leo up here for a second. There's all the satellites that it's seeing, set to a nominal frequency of 10 megahertz. So let me. So I'm assuming you have everything already wired up, and this thing is, showing the carrier signal from this local television station. Okay, so. But before we go into this, how did we get there? How did I know that 572.309, etc., is a local broadcaster? Well, that's a good question. Let's go to this site right here. Rabbit Ears, what is it? rabbitears.info. Go to the site, to the search map, and there's a little square in the middle here. I'm in Connecticut, so you merely grab the little push pin, bring it over to the Connecticut area right here. And I'm going to open this up full screen so I can get a little bit better resolution. I'm going to zoom in, drag it around, and it's centered on right about on Hartford. Okay, so this program is going to give us all the stations that are within viewing distance and the signal quality, and it takes a whole bunch of things into account, but not local terrain. But generally, we're going to get an idea of what all the stations are that we're able to receive here at our site. So we'll shrink this back down and scroll down a little bit. Once you've got this at your location, you hit the go button, and in a couple of seconds, as you scroll down, you'll get a map of where the stations are. You'll get a frequency here, which is the frequency that you will read on your television. But what we're interested in is the actual frequency, the physical frequency, the RF frequency. So I'm going to use this particular carrier here, this one here, which is channel 31. Well, that's great, but what frequency is channel 31? Well, let's go to another screen here. Wikipedia has all the digital television frequencies listed out for you very nicely. We're going to be using the ones here in the United States. I guess this applies to South Korea, Taiwan, and the Philippines as well. So let's go down to, what did I say, channel 33? No, channel 31. So channel 31, a 6 megahertz wide channel, goes from 572 to 578. The digital pilot frequency that we're interested in for calibrating our receiver sits at 572.310, just 310 kilohertz above the bottom of the band. So that's how you can find signals in your area and what the carrier frequency is that you should tune to in order to perform these tests to see if you're really locked or to do some other type of calibration. Again, I know that this particular station is indeed locked to GPS. So let's fold this down and this, and we're back at 572. And you can see it's not really 310. They've rounded there. So we are sitting at 572, 309.404. Okay. So let's take a look at how I have this set up. We've selected the R2 up here. I'm looking at 2.5 megabits or mega samples with a 64 dissemination, and I'm in the CW mode. So if we want to hear it, there it is. We can hear it, but we're not going to leave that on just because you don't want to hear that the whole time, right? So we'll mute that out. And I'll scroll down a little bit. In order to get the resolution in hertz, if you look here, I'm running a 10 hertz bandwidth. That means from here over is 5 cycles. From here over is 5 cycles. So a 10 hertz bandwidth at 572 megahertz. And we are dead nuts right in the middle here. Now, again, I'm already plugged in with the Leo Bodnar board. Pop that baby up again. And it's got an output frequency of 10 megahertz. Now, in order to do this, you have to have the R2 unplugged from your computer, plug in the Bodnar board, set to whatever your chosen frequency is going to be, and plug it back in again. I'm using the full output, okay, 32 milliamps enabled. So now I'm looking at this and I'm going, how do I know if I'm locked to that GPS? Well, here's one way you can tell right off the bat, very, very quickly. Let's bring that back up again. is simply shut off the drive. When this radio comes up, when you first power up, the radio has to make a decision. Am I going to use the internal clock that's in this radio, or let me see if anybody's providing me with an external clock? And I have been. So that's why I know it's locked to GPS. But how do you prove that? Well, I'm going to simply take away by disabling this output, and the receiver is going to stop working. So I'm going to shut off essentially the Leo Bodnar board here. And if I am really on GPS, this is going to stop. But before I do that, I want to look at one more thing here. In order to see this kind of resolution, if you look over here, I am resolving 262,144. This is one of the reasons why I'm using SDR Sharp, because it allows you to get that kind of resolution. It's very slow at that point, but I can see plus or minus 5 hertz at 572 million hertz. So I just wanted to make sure that you saw that. So here we go. We're gonna this is way number 1 to test and see if I'm really locked to the GPS, because once I disable this, the radio is going to keep looking for that input, and if it's gone, the radio is going to stop working. So I'll disable it, and the radio stops. Okay, so now I can stop the radio here, or try logging into it again, but you're not going to be able to start the radio back up because it's gone. The drive, the clock oscillator that's going to drive it, and it won't revert back to automatically to the oscillator. So I'll close that again. I'll try it again. Try to start it one more time. It's going to tell me, oh, there's no air spy there. Well, there's no air spy there because it can't get recognized because there is no drive. So what do? So you go back and unplug it. Let me walk around to the back here, unplug it. Actually, let's do this first. Let's re-enable this. Okay. And I'm going to go back and unplug the radio and let it choose the external local oscillator. 1 second. All right, so I just basically pulled out the USB board, the USB connection to the receiver. So I'm enabled, and I'm going to try to start this up again. And sometimes it takes a second. Okay, there, it started back up again. Okay, and it takes just a second or so to get locked back right on frequency. Let me squeeze that up a little. Okay, so that's number 1. If you disable that oscillator and that radio stops, you know it's been looking to the outside world, i.e. the Leo Bodnar board, and that's the input it has selected. So the next way to do this is to say, let's go back to the Leo Bodnar board again, the GPS clock board, and I'm set here to 10 megahertz, but what I'm going to do is I'm going to move that to 10 megahertz in 1 cycle. So what do you think we should see up here? We should see, because this 10 megahertz is multiplied many, many times to get the oscillator frequency that this radio desires, that if I'm off by 1 cycle, it should push this frequency well off to the left. And so I'm going to squeeze this up a little bit so you can see it when it comes back. All right, so I'm going to try to set that frequency in the GPS board. So you hit set frequency. It doesn't have it in memory. It's searching. And it's going to say, guess what? I can't set it to 10 megahertz in 1 cycle, but I could set it to 0.003 hertz higher than that. So is that okay? Yeah, that's okay. Let's see what happens when I change that GPS drive signal by 1 hertz. So I'm going to say yes. Okay, the radio stops. I'll start it again, and look where that carrier comes up, way over here. Now, this was at 404, 309 kilohertz, 404. So let's move this over. 346. So you can see by moving that one cycle, and it took a second to lock back on again. So that's a second way to know, because you forced that frequency off. So I'm going to stop. I'm going to go back to the Leo Bodnar board again and hit factory defaults, which it defaults to 10 megahertz. It's easier for me than punching in a whole crap load of numbers. So hit default. Okay, what? No PLL lock, no output. So the radio stopped working. All right, and remember where we were at 404. So I'll start the radio again. And it comes back up at 404. Mind you, that's plus or minus a cycle at 572 megahertz. Plus, okay. And let's see. The other way to tell is, let me see if I can do this. So we've done two things. One is we've shut the oscillator off. The radio goes dead because it's listening for an output, an input from an external oscillator. The second way was to shift that external oscillator by one cycle and see that frequency move off. And the third way is I'm going to shut the oscillator off again. Let me bring this up. Okay, I'm going to shut this off and the radio is going to go dead. Okay, here goes. Whoop. And then I'm going to have to reset it. Stand by. Okay, it's going to start back up again. Watch where it starts up and watch what happens to the frequency. Okay, as it drifts around. This is the internal oscillator deciding where it wants to be. You can see that it drifted off, I don't know, 10 or 20 hertz. Now it's drifting off to the right, 10 or 20, a few hertz. And finally it'll settle back to some frequency. So, kind of a recap. 3 ways to do it. While you have it running on GPS, disable this. If disable the enable button here. If that goes dead, that means that the radio was looking at that input and you took it away and the radio lost its mind. The second way is to shift that drive frequency one cycle and see how far the radio comes up when it gets locked on. And the third way is when you return the radio to normal operating off of the internal oscillator, you will see it drift back and forth till it gets on frequency. The other way you could do this is to move this to some frequency. Since I know the station I'm looking at is locked to GPS, that means that if there's any drift, it's going to be in my radio. So if the temperature in my room changes, either plus or minus, it's going to move slightly back and forth off frequency. So this is one way of actually making sure and sort of calibrating the radio to make sure that it really is on frequency. So again, if you go to this page, let me go back. It's called rabbitears.info, and you go to the search map area. The pin starts off in the middle of the United States. I'm not sure if you can do this for other countries, maybe. Drop that pin over in your area. My mouse action is pretty bad here. Take that pin and put it just about where you're located. That's good. Minimize it again, and then hit the go button. The go button will give you all these different frequencies. Choose one, and they're very, very close in frequency. Again, I happen to know that this one, channel 31 RF, is actually locked to GPS. So I do indeed know that this module, this R2, is locking to the Leo Bodnar GPS board input. What's the frequency of RF31? Well, it's over here on the Wikipedia page. RF31 is 572 to 578 and 572 310. They round it up. That's the frequency where you need to look for that signal. I'm just using a short clip lead for an antenna, so frequency is, the frequency is there, but the amplitude of the station changes pretty much. So, any questions? Let me know. Again, these things are all sort of stream of consciousness. Everything makes sense in my head. It might not be coming out of my mouth the same way as I'm thinking about it. But I saw this on a lot of the forums as to how to calibrate and how to get your receiver to drive off of the GPS board. And also, I really want to know, because there's no other indication for it. So if you have any questions, let me know in the comments. I'm going to go upload this now. Thanks a lot for listening, and I appreciate you looking at my videos. I haven't been here in a long time. If you could, please subscribe and hit that top notification bell. I think I'm only at about 550 subscribers. I really would like to get to 1,000. Thanks a lot, folks. Appreciate it. 73 from the W1 VLF ham radio bench. See you later.